Today, we're diving deep into the absolute headache that is the manual transmission pilot bearing. If you've been turning wrenches in the bay long enough, you already know this tiny component can be a massive nightmare if misdiagnosed. So let's explore exactly how to identify, isolate, and completely prevent these failures from happening in your shop. Here's how we're breaking this down today. 1. Component baseline and types. 2. Root causes of failure. 3. Advanced diagnostic indicators. 4. Collateral damage and teardown. And 5. Clutch service best practices. Let's get right into it. Section 1. Components, baseline, and types. Let's quickly establish the mechanics of what we're actually dealing with when we get a rig up on the lift. Think about it. This tiny little bearing has a massive job. It sits right there in the rear of the crankshaft or the flywheel, supporting and centering the transmission input shaft. When you dump that clutch pedal, the crankshaft keeps spinning at engine speed, but the input shaft is slowing down or stopping entirely. The pilot bearing is literally the only thing preventing binding or heavy vibration between those two totally different rotational speeds. Without this little guy working flawlessly, smooth shifting is completely out the window, no matter how shiny and new your other clutch components are. Now, you're generally going to run into one of 3 bearing types, and each has its own specific Achilles heel. Ball bearings, super common in modern vehicles. They give you low friction and a long life, but they eventually just succumb to plain old wear or getting gunked up with contamination. Then you've got needle rollers, great for high load capacity in a really tight space, but man, they are incredibly sensitive to dryouts, lose the grease, and they degrade rapidly. And finally, the solid bronze bushing. You'll see these in older or heavy-duty setups, and they rely 100% on a thin film of lubrication. No film, immediate failure. Knowing exactly what you're pulling out tells you exactly what failure mode you need to look for. Moving to Section 2, Root Causes of Failure. Let's talk about what actually kills these things in the real world. So what's destroying these bearings? Well, lack of lubrication is a huge culprit. Heat just bakes the grease or oil right out, leading straight to metal-on-metal contact. Then you've got contamination from clutch dust, dirt, or moisture. But let's talk about driving habits for a second. Excessive slipping or aggressive driving, that generates insane heat cycles. Those cycles literally cook the lubrication and accelerate metal fatigue, especially on those sensitive needle roller bearings. And don't forget misalignment. Whether it's a bent input shaft, a sloppy install, or excessive crankshaft runout, you're putting a side load on a bearing that absolutely wasn't built to handle it. Listen to this scenario because we see it all the time in busy fleet shops. A tech does a full clutch swap on a heavy-duty work truck, but skips replacing the pilot bearing to save, maybe 10 minutes? Mating an old, worn bearing with a brand new, tightly gripping clutch is a massive misstep. It's basically a guaranteed comeback. That bearing is going to fail almost immediately, and it almost always leads to immediate, severe input shaft damage. Seriously, never cut this corner. All right, Section 3, Advanced Diagnostic Indicators. This is the fun part where we separate the part swappers from the true diagnosticians. If you're chasing a weird noise, here is your step-by-step diagnostic logic. Step 1, get the vehicle idling and push the clutch pedal all the way to the floor. Listen closely. Do you hear a grinding, squealing, or chirping sound? Okay, Step 2, let the pedal completely out. Step 3, does the noise instantly vanish? If it does, you've easily verified that the pilot bearing is the culprit. Why? Because the pilot bearing is only under load, and therefore only screaming at you when the clutch is disengaged, and there's a speed difference between the crank and the shaft. Now, this is absolutely crucial because it's one of the most common misdiagnoses in the shop. People mix up pilot bearings and throw out bearings all the time. But here's the rule. A pilot bearing makes noise strictly when the clutch is fully disengaged. A failing throwout bearing, that's going to give you noise patterns that change or happen outside of direct, full disengagement. Pinning this down early saves you from tearing into the entirely wrong side of the clutch assembly. Here's another brilliant shortcut for separating clutch drag from a bad pilot bearing. Say a customer comes in complaining about stiff gears or the car creeping forward at a stoplight with the pedal pushed. Try this. Shift the gears with the engine running. If it feels super stiff and resistant, that input shaft is likely still spinning, forcing your synchronizers to fight for their lives. Now kill the engine. Does it suddenly shift smooth as butter? Boom! You are likely dealing with pilot bearing drag, binding the input shaft to the engine, not worn-out synchros or a bad hydraulic system. Which brings us to Section 4, Collateral Damage and Teardown. Time to look at the physical carnage once we actually confirm a failure and pull the transmission. So you pull the transmission back, and hey, quick pro tip here, always use a proper blind hole puller for a seized bearing. Forget that old trick of packing it with grease or wet bread. You're just asking to hydraulic lock and damage the crankshaft. Anyway, once you've got it out, what are the definitive visual cues that point to severe pilot bearing overheating versus just normal expected wear over 100,000 miles?
Well, the visual signs are pretty stark. If you look at it and see blue or black scorch marks on the bearing or the shaft, yeah, that thing was cooking. That definitively indicates excessive heat buildup. You'll also usually see visible scoring right on the tip of the input shaft where the bearing rides, and the easiest test in the book. Just stick your finger or a tool in the bearing and give it a spin. If it feels gritty, catches, or fights back, that rough manual rotation confirms the internals are completely shot.
Ignoring a failing pilot bearing is an absolute catastrophe. Let's look at the collateral damage. It chews up the input shaft surface to the point where the whole shaft needs replacing. It throws off the clutch disc and pressure plate, introducing uneven wear, hot spots, and drag. That drag then beats up your synchronizers, leading to gear clash. Suddenly, a cheap little bearing failure snowballs into cascading drive time damage, drastically inflating the repair bill and turning a routine clutch job into a full-blown transmission rebuild. Ouch. Let's wrap things up with Section 5, Clutch Service Best Practices. How do we standardize our shop protocols so these failures never even start? Here is your rapid inspection checklist for any standard clutch swap. First, verify your bearing installation depth and alignment. It absolutely must sit flush and true. Second, use the proper lubrication. Base this strictly on the specific bearing type and operating environment. Remember what we said earlier? A bronze bushing needs something completely different from a needle bearing. Third, rigorously inspect that input shaft for any scoring or runout. And finally, before you tap the new bearing in, check the crankshaft bore condition. Make sure it's clean and totally free of burrs. And this brings us to the golden, non-negotiable rule. Always, literally always, replace the pilot bearing during a clutch replacement. Period. It operates silently when it's healthy, but announces failure clearly when worn. Catching it early prevents that whole cascade of drivetrain failure we just went over. A pilot bearing is a tiny fraction of the cost of the transmission damage it can cause, so never, ever skip it. So I'll leave you guys with this provocative thought. Will standardizing these advanced diagnostics and inspection protocols permanently eliminate costly clutch comebacks in your bay? Mastering this little component isn't just about silencing a squeaky pedal. It's the absolute cornerstone of bulletproof drivetrain reliability. Take these diagnostic indicators, implement the inspection checklist we reviewed today, and elevate the standard of your shop's manual transmission services.